Good morning, everybody. My name is Kurra Kiran. Today, my subject is design of machine elements. And here you can see that my topic is stress strain diagrams. Here we can observe that introduction to stress strain diagram. Stress strain diagram graphically represented the relationship between applied stress and resulting strain in a material, and they are essential tools for understanding the mechanical properties of material. These diagrams helps engineers to determine how materials deform under various loads. Here we can observe that introduction to stress strain diagram is nothing but actually it is a graphical representation, and it is a relation between stress and strain. With the x-axis it have stress and y-axis it have strain, and for this graphical representation we can easily understand the deformation of various load and different material for the easy understanding for the engineers. And uh, and here we can see that basic definition. Stress is the force applied per unit area within the material measured in Pascal. We know stress is nothing but force by area, and the unit of the stress is Pascal. And other thing is strain is the deformation or displacement per unit length caused by stress. Expressed as the ratio or a percentage. Strain is nothing but change in the length or change in volume. Here we can see that the units are unitless because of both have length have the meters, so they can get cancel each other, and there is no any units. And the stress and strain diagrams plot stress on the y-axis and the strain on the x-axis, just I can say that. And here we can observe types of stress strain curves. The most common types of elastic, plastic, and failure region within the curve. In the stress strain curve, we can observe the different types of deformation like elastic and plastic and failure region. We can understand each and everything. Here, plastic behavior is a reversible deformation where the material returns its original shape. Actually, plastic behavior is nothing but it can deformation and it will gain its original shape. It is called plastic, and also we can call it as a temporary deformation. And plastic deformation occurs when permanent deformation happens after the elastic limit is exceed. Plastic is nothing but it can't get its original shape, so we can call it as plastic. And other name of this deformation is we can call it as a permanent deformation also. And key features of the diagrams. The elastic limit marks the maximum stress where the material still behave elastically, and the yield point indicate the onset of plastic deformation. Yield point means nothing but in graphical curve we can observe that there is a yield point means nothing but highest maximum point on the graph. And the ultimate tensile strength is the maximum strength the material can withstand before failure. Here we see that elastic region. In the elastic region, stress and strain are proportional following Hooke's law. Hooke's law is nothing but stress is direct to proportional to strain. It's not nothing but we can call it as Hooke's law. And also in elastic limits only Hooke's law can valid. And the slope of the region is called the Young's modulus or modulus of rigidity. Because of in Hooke's law we can say that the slope region is Young's modulus, because in elastic limit stress is directly proportional to strain. So that's why we can call it as Young's modulus. And other thing is materials return to their original shape when the stress is removed within the region. This is also one of the point. And plastic region. Beyond the elastic limit, materials undergo permanent deformation in the plastic region. Just we discussed that plastic region means nothing but material undergoes permanent deformation. Permanent deformation means nothing but it can't get its original shape. Once it can break means we can't join it again. That is called as plastic region. And strain increases with little or no increase in stress in the region. That one point we need to notice that. Another thing is the material eventually reaches a point of failure. Yield point or yield strength. Yield point or yield strength is nothing but stream. Uh, the first point we can observe that the yield point is where the material begins to deform plastically, and yield strength is the strength value at which permanent deformation start. Yield point is nothing but deform plastically means it is there is permanent deformation, and yield strength is try to starting the deformation of a permanent deformation. And it is a critical parameter in designing structures to prevent permanent damages. And here we can see that ultimate tensile strength UTS. UTS is the maximum stress a material can withstand during the tensile testing. UTS nothing but it's the maximum strength. When a material is in the stress and strain diagram, we can see the graphical curve. At that there is a one peak point. We can call it as a UTL because of it have, at that point it have maximum stress, and it occurs at the highest point on the stress and strain occur before failure. Just we say I said that it is in the graph of stress strain curve graph we can observe there is a highest peak point. At that point only we can call it as UTS. UTS means nothing but ultimate tensile strength, and UTS helps access the maximum load that the material can handle safely. Now, fracture and failure. Fracture occurs when the material break under stress, ending the stress strain curve. At the material break stress curve, at that only fracture point only it can end the curve. Because of the fracture only it can end the curve, and the point of fracture indicates the total strain and stress induced by the material. Through the material only it can break under the ending of the curve, and understanding fracture behavior is vital for the safety and durability assessment. Here, nothing but is understanding the fracture behavior is vital. Vital means nothing but it's important, and also it is safety for the durability. Durability means nothing but time and the ability of the time. And here we can observe that modulus of rigidity, modulus of elasticity and ductility. The Young's modulus measure a material stiffness in the elastic region. Actually, the Young's modulus is measure the stiffness of the elastic region. Here, Hooke's law is valid, no. That's why we can measure the stiffness material through the help of Young's modulus. And other point is ductility refer to the material's ability to undergo significant plastic deformation before failure. Ductility means nothing but it's a time durability, and it is applicable only for plastic deformation. Because of time is only once we can deform the material, we can't get its original shape because of the plastic deformation failure theory. And other thing is both property influence the selection of material or specific engineering. There is application of specific engineering influencer. And here we can observe that applications of stress strain diagram. What are the applications are there? Here first we can observe they are used in material selection and quality control in manufacturing. Quality controlling in manufacturing. And stress strain diagram help predict how material will behave under real world load. One of the application is we can through the diagram of stress strain we can predict the material behavior because of how the durability and their quality control in the manufacturing product we can predict it. And engineers use this diagram to improve safety, performance and durability of structure. And the application for the engineers is they can use this graph stress strain diagram graph is for the purpose of safety and the performance of the material. At the same time they use the use this theory for durability of structure also. Here we can see summary and conclusion. Stress strain diagrams are fundamental for understanding material behavior under load. Actually, the conclusion is nothing but it is a fundamental understanding of material, how the material is there and how the ability and their durability is there for the different material. We can understand through this diagram. That is one of the conclusion. And other thing is they illustrate the key properties like plasticity, elasticity, strength and durability. These are the four key points or key factor we can know through the stress strain diagram. And mystery of this diagram is essential for designing safe and efficient engineering system. These are the things we can see once we can recall what we learn in this session. Here the topic is stress strain diagrams. And the introduction of stress strain diagram is nothing but stress is the graphical representation, and stress is based on the force and area. That one thing we can understand. And also at the same time it is useful for the mechanical property. Through this diagram we can determine the deformation of various load. And basic definition is stress is force by area and the units is Pascal. Strain is nothing but change in length by length. At the same time, we can see the displacement also, and it is no unit. That thing we can understand. And type of stress strain is nothing but there is common type is elastic, plastic, and failure. These are things we need to remember these points. Elastic means nothing but it is a temporary deformation, because temporary deformation means nothing but it can get its original shape, and plastic deformation means it is a permanent deformation. It can't get its original shape. Key point of this diagram is nothing but elastic and yield point, and UTS. UTS nothing but ultimate tensile strength. Elastic region means it's follow the Hooke's law. Hooke's law is nothing but stress is directly proportional to strain, and also plastic means nothing but it's a permanent deformation, and yield point or yield strength is nothing but it's a deformly plasticity, and yield strength is the deformation of through yield strength is permanent deformation starts at the curve of this graph. At the yield strength is nothing but it can start the permanent deformation. At that point we can call it as yield strength. And UTC is nothing but just we discussed that is the before failure it can happen because it have the maximum load of material. And fracture and failure. Fracture is nothing but material breaks under stress. That one thing we need to remember. And also modulus of elasticity and ductility means nothing but stiffness, and it undergoes the plastic deformation. Applications are mainly it is control the manufacturing, and we can predict the behavior of material. This is a summary. And at the last, and thank you.